Assalamu alaikum and good day to all. Today, I, Muhammad Mahfuzur Rahman, am here to present about my PSM2 and the topic title is Securing Integrity of Big Data in Cloud Computing using Algebraic Signature. And I have been supervised by Dr. Syed, Hamid, Hussain, Madni. Now for the contents of this presentation as follows. We have from introduction, user's aim, question, objective, scopes, and finally the conclusion. So let's now move on to the introduction part. Cloud computing is a paradigm for providing pervasive, excessive, on-demand network access to a common pool of computing resources like network servers, software services that are quickly provisioned and released with little maintenance, effort, and service provider whatsoever. Now moving on to the big data. So big data is a term associated with analyzing, continuously extracting information from dataset that are too large and complex for conventional data processing technology. Application to handle. Big data technologies are used for data mining, data analyzing, and data sharing for large datasets that can be viewed, stored, or evaluated using current technologies, processor, or applications. Now move onto the problem background. So there are four problem backgrounds that are cloud server provider is not fully trusted. Second one is there is no need there is a need of remote data ordering scheme to show the integrity of the data. Typical data ordering methods needs relative data auditing involving numerous processes that takes a lot of time and processing resources. And the current data auditing schemes still lack the state of the art data auditing schemes. Now moving on to the research questions. So the first research question is that what type of big data need to be selected for conducting the experiment? How to minimize the auditing processes and connectivity cost on both the user and the cloud server? And which simulation platform to be utilized to evaluate the process methods effectiveness? Now moving on to the research aim. The aim of this study is to contribute to propose a new auditing model based on algebraic signature, which will be more cost effective, reduce computational communication and storage overhead, and will ensure a data confidentiality and integrity during data auditing. Now, the research objectives. The first objective is to select types of big data that is to be experimented on pieces of data involving video files, music files, medical records, emails, and PDFs. The second is to suggest a cost-effective remote data auditing approaches for cloud computing storage that minimizes processing and connectivity cost on both the customer and the cloud server. Finally, to test the proposed method by employing significant analysis and testing in the simultaneous situation like Google Cloud Platform Services in infrastructure as a service. Now, the research scopes. This research will focus on the analysis of methods on remote data auditing in cloud computing for big data. The second one is to study. The study is to experiment on pieces of big data involving video files, music files, medical records, emails, and videos. And this study will develop a modern data auditing approach that has low computational, and storage overhead. Now moving on to the literature review. Several papers have been taken in to comparing the existing data auditing schemes. So these are the headers that have been taken to compare those papers. First is the reference, then the problem or solutions, problem or issues, methodologies, tools, parameters, the techniques used, the achievement they have had, and the limitation of the work. The the data routing models have been classified in the five groups, which are the Markov hash tree, cryptographic techniques, blocking technology, Delphi-Hellman, and Algebraic signature. From the literature review, I have found that most of the current data schemes still lack the state-of-the-art of data scheme involving security measures and need refinement regarding computational cost, storage cost, and commissional cost. For this cause, a new data scheme is presented using algebraic signature, which maintains its confidentiality and integrity during data auditing and requires low computational cost, storage cost, and combinational cost. Now for the solution. The solution is the algebraic signature. Because algebraic signature has homogeneity and algebraic properties, it can be used in remote data auditing flows. An algebraic signature are described in a finite field, and one of these algebraic properties is that the signature of the certain blocks equals to the number of signatures of the corresponding data block. A huge file can be compressed in a small string using algebraic signature. And finally, this method requires less computational storage and computational overhead. Let's see how the algebraic signature works. Suppose using the small bit string where d1, d2, and up to dx includes several data blocks, and L represents the algebraic signature parameter. So as you can see, the data block D has been compressed into an algebraic signature using the following formula. Now let's take a further step. Let's assume the two significant data files A and B compromises of X blocks, which can be referred to as subblocks of A1, A2 up to AX, and for the B, B1, B2 up to BX. And the following algebraic property can be seen from the following. As you can see from here, we have taken the tried to create the algebraic signature of A and B. Then the A and B has been divided into subblocks, and the algebraic signature is created. And from here, A and B is taken common, and altogether make a single algebraic signature of the two files. So from here we can see that the two large data blocks of A and B has been compressed into a small string of signature A plus B. Now moving to the methodology. Three steps have been taken in the research framework. The first one is data selection, the second stage is design and test, and the third phase is implementation, analysis, and discussion. For the first phase, I had to study the characteristics of big data and understand the data and observe what type of data can be used. And the output was the concept of characteristics of data, the types of data that is selected, some of the big data consisting of video files, music files, medical record, emails, and videos, and the size of what type of size of the files should be taken. The second phase is test and design. First, we need to test the model, then design a system model that compromises of users, customers, and TPM, and test the scheme if it has data integrity and confidentiality. The output that it will have is the data writing scheme will be developed, the model will be analyzed, and the testing of the proposed scheme will be done. And for the third stage is the implementation, analysis, and discussion. The experiment will be run on the model. The analysis will be done based on the computational cost, combinational source, and test time. And the findings of the experiment will be discussed. So the output will be that as experiment will be supervised, the scheme's most appropriate and usual technique will be selected, and the results will be presented. Now moving on to the dataset. For the sake of the experiment, I have used 5 different types of data, including the medical, email, PDFs, music, and video. Each compromises of each different size, like for 1 MB, 50 MB, 500 MB, and 1000 MB. For the medical, email, and PDF and BSC file compromises of 1 MB and 50 MB, and the videos is for 500 and 1000 MB. Now let's move on to the design. As you can see, the system model consists of three entities, where is the customer, third-party auditor, and the cloud. Now let's move on to a detailed system model. So as you can see, it has the detailed system model stages have 5 stages, where there is the creation, parameter creation, where the customer and the TPA will create its representative parameter security parameters, and there is the signature creation, where the customer will create the signature, algebraic signature of its file and pass it to the TPA, and there is the challenge creation stage, where the customer will give a challenge to the TPA, the proof creation stage, where the TPA will send the challenge that has been given by the customer to the cloud, and the cloud will send the proof, and the TPA will receive the proof. Then final stage is the verified proof. The proof that has been given by the cloud, the TPA will verify it and send it to the customer if the proof is correct or not. Now moving on to the research results and analysis. The research results, the experiment is done on big data where 30 samples of 1 MB, 50 MB size of metric files, music files and PDF files and email files were taken. And similarly for the largest files, 500 MB and 1000 MB for video files. The purpose of the experiment is to see how much time, computational cost, and communications cost is needed in order to create algebraic signature for each file. Now moving on to the results of the computational cost. Digital file, music files, email files, and PDF files. These are for the 1 MB ones. As you can see, the blue represents the proposed model for the local side. This is for the customer side, and for the proposed model cloud side, on the orange one is for the cloud side. And you can also see the additional of the red and the green. This is for the reference. I am comparing the Zhang and the Yan. These both are from the based on blockchain. So from the results, it can clearly be seen that the local side and the cloud side had a better performance than the blockchain ones. But for the email files, you can see that there is no comparison done. It was because the email files were too small to compare. Now moving on the comparison, as you can see here, the medical files on the local side had a 65% less computational cost than the yen ones, and 75% from the Zeng ones. Similarly, the music files had 45% and 55% represent, and for the PDF files there is 65% and 75%. Now moving on to the cloud side, the yen is the first one and the Zeng is the second one. For the medical files there is 45%, and on the Zeng one is 55% less than. For the music file, 35 and 45, and PDF is 55 and 65. Now moving on the results of the competition for 50 MB. As you can see that only 3 of them is taken. Email file was not taken because it was very small to take. So as you can see, as before, the, the proposed model is significantly has less computational cost than the Zheng one and the Yan one. This table represents the comparison for the 50 MB.
where you can see that the medical files and the music files and PDF files on the local side had significantly less amount of computational cost. And also for the cloud side, the results are as shown. Result cost of computational cost for 500 MB. The video files were selected for this one. You can see the comparison was not done because these files were too big for them. From this we can see that the local side and the cloud side. The cloud side had a significant increase in computational cost, an average of 1.5 times bigger. This was because for the accessing from the cloud and the latency too. Similarly, for the 1000 MB2, we can see a similar result as before, where there is a significant increase, almost an average of 1.5 MB, 1.5 greater. Moving on to the results of computational cost. As you can see, there was no comparison done because in the Yang and Zen, there was no mention of computational cost. This is the computational cost for 1 MB. As you can see, as the file size increases, the computational cost also increases. Least computational cost. Now moving on to the computational cost of 450 MB. From here, you can see that as the file size increases, the computational cost also increases. From here, you can also see that the musical files had the least amount of computational cost. Now moving on to the storage cost of for TPA. For this one, the storage cost was on the file size. The file size represents the number of set of algebraic signature. The customer will create algebraic signature and put it in Excel file, which then file will be sent to the TPA. From that file, the TPA can then refer to that and select check if the with the cloud if the file is correctly being stored or not. From this graph, you can see that as the algebraic signature size increases, the file size also increases, and it is a proportional, and it increases proportionally. But you can also see that the when the set number increases as a high range of increase, like for like 200 algebraic signature, only a 15 KB size is being created. So a very less amount of cost is being uh, have been stored on the TPA. So the TPA have a very least amount of storage cost on itself.
Now, finally, the conclusion. Let's first see what the achievements have been made. The dataset have been used where 30 samples of data for each file size category is to be used to draw conclusions about the purpose scheme. The, the algebraic signature experimental program has been achieved by creating the experimental program using Python version 3.97 and the PyCharm. And the proposed model computational cost is compared with Yan and Zhang representatively, and it is clear that proposed scheme has less computational cost compared to Kim. Now let's see the constraints of the code. When designing and creating the proposed scheme, it was decided that the cloud service to be used is the Amazon Web Service, but the account had a problem as it could not identify the debit card. Similar problem was reflected with the Azure account too. But finally, the Google Cloud Platform worked, but it had the limitation of free access up to 90 days only. The suggested improvements. While the proposed scheme has proved its word, which is proved in results and analysis section, but there are still many ways the model can be improved. But the future studies should focus on the model's additional qualities and how they might be used to speed up the process, and how to add multiple batch auditing processes, and finally how to add the dynamic operation. So thank you very much for watching my presentation. Assalamu alaikum.